Hi, we are going to see the insertion sort. What is insertion sort? First, what is sorting? Sorting is arranging the data in ascending or descending order. Insertion sort is a very easy to implement and it is simple and efficient comparison sort. So in this, the one element is checked with the preceding element. If it is lesser, it going to swap. In this algorithm, each iteration removes an element from the input data and inserts at the correct position as we know. The choice of the element is being removed from the input is random and this process repeat until the last element. Now we are going to see the advantages. So the advantages are it is very simple to implement as I already said, and it is efficient for the small data, and it becomes complex for the big data when hundreds or thousands of data are given. It becomes more complex to sort it. If the input list is pre-sorted, then the insertion sort takes place with the d number of inversions. So it is always stable and it maintains a relative order of input data, and the output will be also of the order will be also of the same order. It requires only a constant amount of O of 1 additional memory space, and it is always be online, so insertion sort can sort the list as it receives it. Next we going to see the algorithm. This the first element is being picked. It is already sorted, so it is the first element. We don't want to compare, it stays in the same position. Then the pointer is incremented, it goes to the next element. The next element is being compared to the first element. If it is set lesser, it going to swap. Then the point is incremented, it goes to the next element. The next element is being compared to the index 0 and 1. If it is lesser, it going to swap. This process is repeated until the list is sorted. So next, will be the representation of this insertion sort. So the first box represents the unsorted elements with the unsorted with the given unsorted order. The second box is a sorted elements with the x in the middle and the lesser elements in the left side and greater elements on the right side. As you see, the implementation will be thought later. So the example, the given an array with the 6 8 1 4 5 3 7 2. Our goal is to put them in a ascending order. First element 6 is taken, so if the index 0, we don't want to compare. So the next element, the pointer is incremented, it goes to the element 8 with index 1, so it compares with 6, it is greater, so we want to put them in, it stays in the same position. Then the pointer is incremented, it goes to 1, the 1 is being compared with the 8 and 6 with the index 0 and 1, so it is lesser, it going to swap. So it goes to the correct position at index 0. Then the pointer is incremented, goes to 4, 4 is being compared with 8 and 6, so 4 is lesser than 8 and 6, so it's going to swap at the index 1. So then the pointer is incremented, the pointer goes to 5, 5 is compared with 8 and 6, it is lesser, so it's going to swap. And the 5 is compared to 4 and 1, it is greater, so it stays at the index 2. Then the point is incremented, goes to the element 3, the element 3 is compared with the 8 6 5, so and 4, so it is lesser than, so it goes at the correct position at the index 1. So the point is incremented, it goes to the next element 2, the 2 is compared to 8, it is lesser, going to swap. Then the 2 is compared to 7, it is lesser, going to swap. Then the 2 is compared to 6, it is lesser, going to swap. When the 2 is compared to 5, it is lesser, going to swap. When the 2 is compared to 4, it is lesser, going to swap. When the 2 is compared to 3, it is lesser, it going to swap. Then the last, the 2 compares with 1, 2 is greater, so it stays at the same position. So as you see, the array is sorted. So the biggest disadvantage is that it requires more time as compared to the other sorting algorithms, and it is, as I already said, it is very easy to implement, and it is more efficient than other sorting algorithms. So as it is useful for you, I hope so. Thank you for watching.
Now we are going to see about selection sort. Selection sort is a simple sorting algorithm. This sorting algorithm is an in-place comparison based algorithm in which the list is divided into two parts. The sorted part at the left end and the unsorted part at the right end. The smallest element is searched from the unsorted array and swapped with the leftmost element, and that the element becomes a part of the sorted array. This process continues moving unsorted array bounded by one element to the right. This algorithm is not suitable for large datasets as its average worst case complexities are of big O of n square. The advantages of selection sorters is performs very well on small lists. It is an in-place algorithm, does not require a lot of space for sorting. So only one extra space is required for holding the temporal variables. It performs very well on items that have been already sorted. The algorithm of selection sort is as follows. The pseudocode of the selection sort is as follows. And the procedure of the selection sort is as follows. Here we are taken an array of 6 elements as an example. It is an unsorted array. The elements are 14, 33, 27, 10, 35 and 19. For the first position in the sorted list, the whole list is scanned sequentially. The first position where 14 is stored. Presently, we search the whole list and find 10 as the lowest value. So we replace 14 with 10. After one iteration, 10, which happens to be the minimum value in the list, appears in the first position of the sorted list. So now the array becomes 10, 33, 27, 15, 35 and 19. For the second position, where 33 is residing, we start scanning for the rest of the list in the linear manner. We find the 14 is the second lowest value in the list and it should appear at the second place. We swap these values. And now the array becomes 10, 14, 27, 33, 35 and 19. So after two selections, two least values are positioned at the beginning of the sorted manner. The same procedure is applied to the rest of the items in the array. And then the array becomes 10, 14, 19, 33, 35 and 27. And then the array will become 10, 14, 19, 27, 33 and 35. And now the sorted array is as follows: 10, 14, 19, 27, 33 and 35. So applications of selection sort. Selection sort almost always outperforms bubble sort and genome sort. It can be useful when memory writes its costly operations, while selection sort is preferable to insertion sort in terms of number of writes is theta power n swap versus big O of n squared swaps.
Next comes the bubble sort. Bubble sort is also called as sinking sort. Bubble sort is the simplest sorting algorithm that works by repeatedly swapping the adjacent elements if they are in the wrong order. This algorithm is not suitable for a large number of elements because its average and worst case time complexity is quite high. Why bubble sort? The advantage of bubble sort is that it requires very less memory other than the array or list. It is comprised of very few lines of code. And here is the algorithm for bubble sort. Example for bubble sort is given here: 6, 13, 4, 10, 16. First we compare the two elements 6 and 13. Here 6 is less than 13, so no swapping will take place. Next we will move to the next two elements 13 and 4. Here 13 is greater than 4, so swapping will take place between 13 and 4. Now we compare 13 and 10. Here too 13 is greater than 10, so swapping will take place. And then we compare 13 and 16. Here 13 is less than 16, so no swapping will take place. And next we come to the first, and in the second pass we compare the first two elements 6 and 4. Here 6 is greater than 4, so swapping will take place. Now the elements are all in their ascending order of arrangement, so no need of further swapping. So therefore we have swapped the elements using bubble sort. And the main disadvantage of bubble sort is that the running time is big O of n squared, which is highly inefficient for larger data.
Hi guys, we are now today going to see about quicksort. Let's start with this definition. Quicksort is a popular sorting algorithm that's often faster in practice compared to other sorting algorithms. It utilizes a divide and conquer strategy to quickly sort data items by dividing a large array into smaller arrays. But quicksort is not more preferable than other sorting algorithms. Okay, then now we are going to see about quicksort's pivot algorithm. Okay, it follows 8 steps. Step 1, choose the highest index value as pivot. And step 2 will be take two variables to point left and point right of the list excluding pivot. Left points to the low index, right point to the high. While value at the left is less than the pivot, move right. While value at the right is greater than pivot, then move it left. If both step 1, 5, 6 does not match, swap left and right. If left is greater than or equal to right, the point where they met is the new pivot. Okay, now let's see the quicksort function algorithm. It's so simple. Quicksort's array and start and end. Where to start and where to end, and the array size is more important. If condition start is less than n, then do the following, otherwise it exits the function. This is all about quicksort algorithm. Meet you in the next video. Thank you for watching this.